maybe before, so we're going to go to page 15 here, but I did assign some pages. Trying to think where they were. 11 and 12, right? So something you need to be very comfortable with, right? So for example, on page 11, we had 2 classes with the marks given. So these are all the marks for unit 1, unit 2 tests, I guess 2 different units. And so I expect you to be able to enter both of them, right? The idea is enter this into L1, this into L2, and then always give me the mean, standard deviation, and in this case they wanted median and mode. I don't know if I talked about this in the video, but the easiest way to find the mode is to sort your data, sort it, and then it'll just pop, like if you scroll through it, you'll see which one shows up most often. And so I expect you to have this. So at first glance, if you analyze this, like if I ask you, okay, like what does this tell us? You can tell that the averages are basically the same. Well, no, they are exactly the same in this case. But then when you come down to standard deviation, you're like, wait a minute, right? What does this tell us? So this is kind of where we kind of park and spend some time on. You can tell that for the second unit, there was a lot more of a variation. You can say it varies more, it's more spread out, right? Data on average is further from the mean here. And over here, it's a bit more clustered, right? So something that you need to be able to tell me just by looking at standard deviation. And I'm using different wording because I don't want just copy paste. I want you to use your own, but you can definitely say, right, clustered, spread out, more consistent, less consistent, right? Things like that. So if you want to add that to your study sheet, right, high standard deviation means, right, all of these things. And I did talk about it. There's a page further at the beginning where I talk about the differences. Higher range, lower range. That's another thing that is true about standard deviations, right? And so you'll see that. Then I had the example here, right, where we have the average housing prices per year. So we kind of break it down per year, and then we can also break it down per city. Okay. So I kind of organized it a little bit. I gave you a table, but here you have all the averages and standard deviations by city, and this is by year. So we enter this into L1, L2, L3. Right? Yes, it's a lot of work, but the calculator does everything for us. And so if you analyze this, you kind of want to look at which one has the highest average housing price, right? That's one thing you can talk about. So it seems like it's Vancouver, which is no surprise. Right? Vancouver and Toronto are probably going to be your highest. Yeah, there we go. And you know, this is very dated. So that's besides the point though, right, of this exercise. But then you look at the standard deviations, right? Like 15,000, and then you go look at, so 15,000, so what's the lowest standard deviation ever on this particular table? You go over here, 2,166. So in Regina, right, the housing prices are closer to the mean. It's not so varied, right? And it has probably one of the lowest housing prices. Well, Halifax does too, but so you would kind of want to look at the average housing prices, talk about that, but then also talk about the standard deviation if I ask you to do so. Okay, so it kind of goes hand in hand. Which one has the highest standard deviation here? Is it Yellowknife? 20,000. Yeah, Yellowknife has the highest standard deviation, which tells me that there's a great variation in the housing price, right, from year to year. So keep that in mind. Okay. All right, let's go to page 15 now. Just gonna have my key here ready to go. representing data graphically. So this is very important section of this unit, and there are 4 ways to do that. I would say it is the safest thing is before you start, find the MCTs, the standard deviation, and the range, right? So enter it into your L1, and then just go one variable stats. Okay. And just go ahead and find that, and then determine what that is. Line plot is one of them. We've already covered that. I'll give you a take-home AC to try that as well, this part. Frequency table or chart, they're the same. This is a requirement for 3 and 4. So this is in and of itself a way to graphically or organize your data, but then you need this to come up with 3 and 4. With a histogram, similar to bar graphs, but they're connected. I just want to make sure you understand that. Connected bars. And then you have a frequency polygon. You connect the dots with straight lines. That's what I want you to think of there. So these are my four ways of organizing data. Okay, and maybe right here, just if you review down the road, okay, line plot, what does that look like? You have a line like this, and let's say your average is here, and then you go ahead and plot those points, organize it like that. Frequency table or frequency chart, I'm going to go off to the side a little bit. It will look like this. It is a table, as you can tell. Okay, and you have the intervals, you have the tally, and you have the frequency. Okay. Interval, tally, and so right now, if it's like, I can't really make out what that's saying. Later on, when we have done those, you will know exactly what those headings are. But it's interval, tally, and frequency. Okay, this is just so that when you look at it, it's a quick reminder. Histogram, let's look at that one. Histogram, you have an X and a Y axis, and you kind of just, they should all be the same width, but that's a histogram. And frequency polygon is when you connect, you make a dot, you connect it to the next one, you connect it to the next one, and then you bring it back down. That's what a frequency polygon is. So there are your 4 ways of graphically representing data. The idea is this: if you just have a bunch of numbers, you don't know what it's telling you. You have no idea what it's telling you. Imagine like 1,000 numbers just here. What does it tell you? We don't know. Okay. So our job is to arrange it, sort it, and then put it in a way that we can actually see what it's telling us overall. Okay. Line plot. I'm just reminding you how to do it. Okay. Use your min and the max to determine the scale. Add labels and units. Place data points on the line. Stack if there are multiple entries. Label your MCTs. Okay. Range is not an MCT. So maybe what I will say here, it's a good idea to sort. It's a good idea to sort your data every time. So here's the frequency table. That's new today. Okay. Frequency table, you have 3 columns, and you have interval, tally, and frequency, just like I told you now. You sorted L1 to enter your data. we determine the number of intervals, right? Determine the number of intervals. Anywhere between 5 and 12 is ideal. But here's what I'm going to tell you. On an assessment, you will be given the number of intervals to be used. Because I found it very difficult to mark if I let students decide, because technically you can decide how many intervals, how many bars your graph is supposed to have. But I'm just going to tell you, hey, I want 6 or 7 or 8 or whatever the case may be. Calculate the interval width. Okay. So calculate the interval width. So we go range divided by number of intervals or rows. Okay. You can round this number. I will give this a different highlighter here. Range divided by number of intervals or rows. That's how you find the interval width. Start your interval column and use the interval width. Use a low enough value to include the lowest value in the set. That's also important. If a value falls between two intervals, place it in the lowest interval. I'm going to use a different color for that one because this comes up quite often. If a value falls between two intervals, we always put it in the lowest one. What are you talking about there, Mr. Dixon? So let's imagine you have 65. That's the number you have to put in an interval, and then you look at this. You like 60 to 65, 65 to 70, right? So the value that you're considering, you're like, should I put it in this or in this? Because there's 65, and it's always in the lower one. You put this in the lower one here. Okay. You don't put it in the higher bracket, you put it in the lower bracket if that ever happens. Okay. The following shows a frequency table. There it is, that frequency table is right here. Showing the heights of planted trees. All right. I want you to, for a moment, ignore the midpoints. Okay. For now, I want you to be like, okay, this is what a frequency table looks like, and I'm going to highlight this part. You will create this shortly, but for now, I'm just going to jump right to it. You have the interval, you have the tally. This is where you count it as you go through your data set. You count how many fall in each one of these widths. Okay, so you happen to have 3 that are between 100 and 125 centimeters. You happen to have, this is 5, right? 5 and 3, 8 that follow. So the frequency means you have 3 trees or plants that fall between 100 and 125. You have 8, right? 5 and 3 is 8 plants that are between 125 and 150. You've got another 3 plants between 150 and 175, and you've got another 12, right? This is 5, 5 and 2. This is 12. So you do the frequency part at the end once you've tallied it. Tally is like your running count, okay? Then you come up with this. Okay? So this is your frequency table. What is the width of my interval? I'm going to write this down here. If you look at it, what are we going up by? You can tell we're going up by 25, right? You see that? In this case, it's very easy to see. So my interval width is 25 centimeters. That's very important to observe. And usually we like nice and round numbers as our width. We don't go up by weird amounts, okay? So it'd be 2.5 or something that's easy to do, and we just want to organize our data set. I'm going to park we're not going to do the midpoints just yet. I'm going to come back to that later. I will always ask you to first look at the frequency table, and then we're going to deal with the midpoints a little later. Let's keep going. Use a frequency table to create a histogram or a frequency polygon. Right? So again, what do we use? We use the frequency table that we've created on the previous page to create a histogram or a frequency polygon. Interval is placed on the x-axis. Frequency is placed on the y-axis. Okay, I'm going to use two different colors. So the interval is on the x-axis always, and the frequency goes on the y-axis. And you're like, what about the tally, Mr. Dirksen? Don't worry about the tally. Tally's just run and count, but once you add them all up, there's your frequency. If you're not starting at 0, use a zipper. Okay, this is also very important. This is the only unit you're allowed to do that. So let's say your numbers are really big and you want to start at 100 here, but then go up by 25, let's say. This is a problem because look, this is 25 and this is 100 here. So we use a zipper like that. Okay. So the zipper allows you, it's almost like saying, hey, we shrink all of that because we just want to focus in on our data set. And so that's the zipper. Okay. Histogram, you create bars that touch and have the same width. Okay. Bars touch and have the same width. Frequency polygon, what does it say there? We connect the midpoints of the intervals. Okay, that's where the midpoints are going to come in. We're going to go back later on and do that. It must end and start, or sorry, start and end, right, by touching the x-axis. Very important. So what do I mean by that? Sometimes you're going to have like, oh, there's a midpoint and there's a midpoint and there's a midpoint. You might be tempted to just say, hey, that is it. No, you have to make sure you close this, right? Make sure it touches the x-axis at the beginning and the end. I'm running out of colors here, but I will say this. You can graph both of them on the same plane. So the frequency polygon and the histogram can both be done at the same time, and I'll show you how I do that. So here we go. I provided you with a nice grid. So here you go with the interval. So what is the interval in this case? That is the height of the tree, right? Height in centimeters. So that's what, so I write down the interval so you know that's what goes there. But really, all you would need there is the height in centimeters. It doesn't matter if you write down interval, that's fine. And then over here, it's the frequency. And within this context, the frequency is the number of plants. So that's what I want you to write, number of plants. Okay, so it could be number of people, it could be number of tests, it could be whatever data you're thrown at, that's what that, just have to make sure it makes sense within the context. All right, this is my 0 here. Watch what I do here. I actually use this I'm going to use these numbers to help me out. I'm going to start at 100 and then go 25, like 100 to 125. And I'm going from 125 to 150 and so forth. So to make it easier on myself, I'm just going to call this 100 here. And then I'm going to say, well, this is going to be my 125. And then you go from 125 to 150. And then you go from 150 to 175. And then we go from 175 to 200. And if you look at your table, that's where it ends. 200 is where it ends. But there's a problem right now. Look at this. This is 25, 25. But from 0 to this is 100. So zipper. Okay, that's what solves your problem there. Okay, zipper. And so what do we do now? We need an appropriate frequency scale. We need a scale for the y-axis. So you look at your frequency table. What's the highest number I reach? Look at your table, and it's 12, correct? 12 is the highest number. So if I say that I'm going up by 1, so I'll make this 5, I'll make this 10, and that's going to be good enough. That's all I need. It'll allow to fit in the 12. So here we go. You might want a ruler. But look, it says the first from 100 to 125, I have 3 plants in that category. So all you need to do is from here to here, we're going to make a bar. So we go up to 3 here. Just make that line and then close it off. And I always like to put down how many plants are in that category. So 3 are found in here. My next one from 125 to 150 is 8. So I'm going to go up to 8. Close that off. And the bars should be touching. Unless there's nothing in that category, these will be touching. So I have 8 plants that are between 125 and 150. Then I'm back to 3 for the next category. And then I have 12 plants from 175 to 200. So I got to go to 12. Make that line. Cut it. This is 12. That would be a histogram. You're done there. Frequency polygon. This is once you do the histogram, the frequency polygon is so easy. You will connect the midpoint. So between 100 and 125, the midpoint is actually right in the middle here somewhere. So I make a dot there. Then I go to my next category. And the midpoint is going to be right here. My next category, the midpoint. So you just basically find the center of each bar, but it needs to happen at the very top of the bar. And here you go. So you connect them. Not quite ready. This isn't ready yet. What do we need? We need to make sure it closes. So we just close it. And I try to aim for the middle of the next bar if there had been one. Okay, so we just extend it there. So I'm going to have a little legend on the side here. This is the frequency polygon. And this is the histogram. So what do you need to make both of these graphs? The frequency table. If you don't have a frequency table, you can't do this. Okay, so it all hinges on that frequency table that I already started off with. now we're going to go and going to have to find our midpoints yet, actually calculate what those are. Watch what it says here. Determine the mean and the standard deviation of this data set. So we want the mean, right? What's the mean and what's the standard deviation of this data set? And I want to make a note here. Can we do that just like this using this table? The answer is we are not provided with each individual height. Right? We're not given that data set where we know every single height of every single plant that we're dealing with. Okay? Therefore, I'll go like this. Therefore, we need to determine the midpoints for each interval. See page 15. Okay. Determine the midpoints. See page 15 for that. Should I? You know what? I'll give you the midpoint is low plus high divided by 2. If you need this on your study sheet to remind you, midpoint is finding the middle, right? So you find the average basically. So you just add the low and the high and divide it by 2. Emphasis on the brackets though. You gotta put the top in brackets, or you gotta go add and then hit enter to make sure you do that first. So let's go ahead and do that on the previous page. So I'm going to go back to 15. Some are still copying. Let's go ahead and do that. All right, so let's do that here. You may need your calculator for this. But to find the midpoints, we go 100 plus 125 divided by 2. Then the next one is 125 plus 150 divided by 2, and so forth. 150 plus 175, divide that by 2, and so forth. And you get 112.5, 137.5, 162.5, and 187.5. Do that right. But I need you to understand that the midpoints, I just added that column. That's not part of the frequency table. Why are we doing this? Why are we finding the midpoints, you might ask? Because we don't know these three plants, for example, that fell in this interval, we don't know the exact height. So we're trying to find an average height for plants that are in here. Then we're trying to find an average height for plants that are in this category and so forth. So we're trying to find the average. So this goes into L1. And this at the very end here, the frequency goes into L2. Let's go ahead and do that. I invite you to do the same with your calculators. So you grab your calculator, go stat, edit, clear whatever is there. 12.5, 137.5, 162.5. Most of the time there's a pattern. If you think about it, you're going up by 25 here as well with your midpoints. And then L2 gets the frequency, so 3, 8, 3, 12. Okay. This is very important. If you miss the fact that we go frequency L2, you're going to miss the entire point of this exercise. So we're going to go stat, calculate, and go one variable stats, just like before. But what do you think we're going to enter? We're not just going to go second 1. We're also going to go comma second 2. We want both of them to enter at the same time. Hit enter. And I want you to focus on what is n here? N is 26. So if you add this up, 3 and 8 is 11, 14, another 12 is 26. So you've got 26 plants. So n is equal to 26. We're considering 26 items. And so you entering this into L2 and including that in your statistic calculation will make sure that you're actually considering 26 plants. Okay? Pay attention to this. If I were to redo this, I'm going to go quit, do this again. If you omit L2, if you just go like this, how many plants does it think you're considering? Only 4, because it's thinking you only have 4. You entered 4 values, so 4. So you have to make sure you include the frequency as well to make that 26. Okay, so I'll make a note here. We're going to say one variable stats, L1, L2, okay, and then we get this. The mean height of our plants is 160.58 centimeters. We are dealing with centimeters here. Oops. Sorry, you can't see that, can you? There we go. My standard deviation, according to my calculator here, is 27.67. We are still in centimeters. N is equal to 26, right? Number of plants. Okay. So I will make an arrow showing that, right? This is the frequency. Think of frequency as how often, right? How often does that happen? And in this case, it happened 26, right? You're dealing with 26 different data points. Okay. So these are your midpoints. And this is your frequency. It's very important that you understand that. let's do a full-blown where we need to create our frequency table. Come with me. 17. Can I ask you to enter all of these values into your L1? So clear whatever is there. Go ahead and find that. Just a quick check, right? 6 by 5. That's 30 data entries that you should be having. And so if you jump all the way to the last one, it should say 30 in brackets like that, then you know you're good. You can also check later when you do your stat calculation. So it says calculate the MCT's standard deviation and range. So let's go ahead and do that. Stat calc. So there's some, do we do the L2 thing here? Nope, because you don't have a frequency table, right? You have literally every single data point given to you. You've entered 30, so you're good to go. You can just go second one like that. One variable stats. L1, that's it. Hit enter. Before I write this down, is that what you get? Mine matches. Okay, good. What does it say here? What does N say? 30, right? So we're good to go. We haven't missed one. So a lot of things we can check as you're doing this. Standard deviation is 951, 49, and my N is 30. What are our units here? You go back here, measured in cubic centimeters per second. So you slap that onto every data point here. The mean and standard deviation is measured in cubic centimeters per second. Okay. We need our range yet. I'm going to do that here. Range. Remember how to do this? Max minus min. So it's 4587 minus 159. And we have 4428. Sorry, I said cubic meters, right? Per second, not cubic centimeters. I don't know what happened there. So get rid of the C in front of the M if you copied it. It's only supposed to be cubic meters. My bad. So we've got a range. We have mean. We still need the median. Okay. The median is given to me by the calculator. And that's also cubic meters per second. And we still need our mode. The MCTs are right, like find all of the. I will sort before I do that. Think of this. Somebody asks you, did you find a mode? Sort of. I don't know. So sort A, second one. They don't pay me for jokes, good thing. That's how I get paid for. So I'm just gonna, I sorted it, sorting ascending order, descending, it doesn't matter. I don't think I'll have a mode. I didn't see any doubles. Every single number is distinct and unique. So mode is NA. There is no mode. Don't put 0 down because then you're saying 0 is your mode. It's not applicable. None. Anything like that is good to go. Okay. Create a frequency table using 9 to 10 intervals. What's up with that? How many intervals are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 in here. So I'm going to use 10 because I already gave you a table. So if I give you a table, just use what you have there. 10 intervals. Okay. There are 10 intervals here. So 10 rows is what your question is going to have. But if you needed to calculate, here it is. you take your, what is the interval again? So to find the width, sorry, I'm trying to think where I should fit this in. To find the width, I'm going to go range, which is, where's my range? I already calculated that. 4428. So if you want an arrow, divided by, in this case, 10. If you divide this by 10, you get 442.8. And that's a very weird amount to go up by. But this is just to help you out, like what would be a good one. So guess what? I'm going to say approximately 500. This is what I'm going to choose to go up by. So my width is 500. I'll tell you a secret. Quite often on the test, I started off for you, so you just have to complete it. Okay. So don't stress too much about this. But this is how I came up with my 500. I went my range, right, from the lowest to the highest is this much difference. If I split this into 10, I have brackets that are about this big. But I'm going to go with 500. This is basically the bar width, guys. How wide your bar is going to be along the x-axis, right? The smaller this number, the narrower your bar. The bigger this number, the wider your bar, okay? Think of it that way. So 500. I'm going to start with, you got to make sure, go to your calculator, you got to make sure you account for your lowest number, which is 159. So to make things simple, I'm going to start from 0, go to 500. That's just like make it work for you because we're trying to organize it. That's all we're trying to do here. And then we're going to go from 500 to 1,000. Right? So you got to know that there's a bit of an overlap here, right? So then we're going from 1,000 to 1,500, and let's keep going up by 500 that way. A lot of fun, eh? I think this unit, at the end, I hope that you'll enjoy it. I know at the beginning it's a little bit of a head scratcher. I stopped at 5,000. That's where I ended up. But you always want to make sure, I'm going to go to my calculator. My biggest value is 4,587, right? So 5,000 is perfect. However, there may be in the homework, I may have given you a table and it doesn't include everything. You know what you do? Ready for this? You just add another row. You go, right? And just keep going until you're able to fit all of your data points. Okay. So now you grab your calculator. Now that you've done this using the width 500, right? I'm going to write that down here one more time. Width is 500, right? That's what I chose to go up by. We're going to now place all of these numbers in the correct bracket. And the best way to do it is to sort it. Okay, this is already sorted. I go to my smallest. Okay, go to the smallest value. I can't do everything at the same time here. I can't fit everything in, but maybe. Hold on. Hey, there we go. So 159 goes in here, right? 187 goes in there. 280, 396, 500. Mr. Erickson, there's 2. So where does it go? Lowest. Always in the lowest. So 500 is going to make this 5. So I always do a cross like that when it's 5. I don't know if you've done this before, but that's how you tally. Okay. So then keep going. 564 is already the next bracket. 881, 946, 991. Now I'm at 1,048. So that takes me to the next bracket. Then it's 1121, 1390, 1393, 1399, 1458. Now I'm at 1557. So then I go to the next bracket. And I just keep going. Oh, wait. Am I okay here? Yeah, 1812 is still good. 1877. 2080, I'm in the next bracket. 2180, 2339, 27, I'm in the next bracket. 3030, I'm in the next bracket. 3058. 4587, what's happening there? I'm jumping, nothing here, nothing here. 4587 puts me in here. And I'm done. And now you're going to check. How many do we need in total? 30. So let's see if this adds up. I have 5 in this category, 4 here, 6 there, 8 there, 3, 1, 2, 1. So let's see here. This is 15, 15 and 11 is 26, and 4 is 30. Yes. So n is 30. Check. Okay, we're good. Sorry. So there it is. You want to copy it? I use my sorted list. Maybe you want to use sorted list, right? For this part. You can do it unsorted, but that's going to be a mess because you're going to be all over the place. Oh, this one goes in the first one, goes in the last one, fourth one, right? And potential for you to make a mistake. So we've created our frequency table. I gave it to you earlier. We've created it. Now we're going to do our graphs. We can do histogram and frequency table, polygon at the same time. Let me stop here. Let's take a deep breath and just see like what happened here. Mr. Erickson, if you ask me to find the mean and the standard deviation, do I need to do the midpoint thingy? No. Why not? Because you have every single data point individually. Okay? If I had done this, let's say tomorrow I give you an AC, and I just give you a table like this. Find the mean and the standard deviation of this table here. Oh, I need to first find the midpoints, right? Write them down, and then go L1, L2. Okay? And then find the mean and standard deviation that way. But if you have every single point given, you just do one variable stats, L1, just like before, and find the mean and standard deviation that way. Okay? You don't need to do the midpoint. That's the difference between, right, just a frequency table or data where you create your frequency table. Let's graph this now. What goes along the x-axis is my interval. But what does it represent in this particular case? It's the flow, right? Flow rates. So I'm going to write it down here. Flow rates in cubic meters per second. Okay, I'm writing it down right at the bottom there. You can't see it. There it is. Flow rates, cubic meters per second. This would still be by frequency. But what does it represent in this case? The frequency. Number of values, Mr. Erickson, obviously. It would be the number of years, right? It's between 1972 and 2001 that we've collected this. So a number of years this happened, that flow rate happened. There we have it. I need to make sure I fit in, right? Actually, I start at 0 in this frequency table, so I'm going to actually start there. 0 to 500, then to 1,000, 1,500, 2,000. If I didn't give you a nice chart like this, you would still proceed the same way. Use a ruler. And it just fits perfectly because I thought it through beforehand. Mrs. Erickson, what if I had used a interval width of 450? Would I have been wrong? No. Your graph would just be slightly different because you would have different widths of your bars, right? So that doesn't matter to me as long as it's consistent throughout, okay? 500 is just much easier to work with. What if I went up by 1,000? Sure, you could have done that. You would have had fewer bars, fewer rows, if you want to call it that way. Everything would be different, but it's still not wrong, okay? So here we go. From what do I need here for frequency? What's the highest number I have? And it's 8. Look at this. The highest frequency is 8. So I'm just going to go, you know what? I'm just going to go one. Every box represents 1 unit still, just to make it easier. You could choose whatever you want for the scale. And now it says from 0 to 500, I have 5. So I'm just going to go right from the y-axis and just go 5 and close it like that. There's 5 years where I had a flow rate between 0 and 500. Then I have 4 the next, right? 4 years, I had a flow rate between 500 and 1,000. Then I had 6. Then I had 8. Three. Oh, that's not 3. That's 2. There we go. 3. And 1. And 2. And then there's nothing, right? 3,500 to 4,000, nothing. So I guess I could put zeros down here up on my frequency table. But then I have 1 year where I had a really high flow rate. Oops, wrong year. Because there are 2 brackets where there's nothing. It's the last one here. 1. That's my histogram. To do your frequency polygon, all you do is locate the middle. These are essentially the midpoints, by the way. And just connect. And you might think, hey, what about this one? Yeah, it's right along the x-axis, right along the x-axis. Then you go back up and we'll close it down. So in this case, go like this. Make sure you close it with 0. So just connect them. You go along the x-axis for those 2 years. So that would be a frequency polygon. I don't know about you, but those numbers meant nothing to us until once you see the graph, you're like, oh, most of the time, the flow rate is 2,000 and less, right? Or less. Having anything above 2,000 is rare, okay? So it's very easy to see and analyze. You could now compare this to a different city, different town, and see maybe if this shifts or what have you. Okay. All right. I'm going to ask you. I will basically assign there's no, you're not making a frequency table on these pages that I'm assigning. A lot of them are just use your calculator to enter. I will say 18 to 22. 18 to 23 I will do, but I will let you get started. 18 you should be able to get done today. Page 18. I'm quite confident that you should be able to do that. Just read the instructions there. Um, you know what? I'm going to change my homework a little bit. So I'll leave the 18 to 23 there, but I will say this. Page 18 and 20. Those are the ones I would really want you to do. And then I'm going to give you a take-home AC. Take-home AC. What is that? That's what it means, take-home AC. So if you're like, you know what, I'm going to first do the take-home AC and then I'll do the homework, sure.